Okay, 8.2. So 8.2 is about the distribution of the sample proportion. And this is very similar to 8.1 in the sense that, in 8.1 we were looking at the sampling distribution of the sample mean because we thought, because I told you that it would be useful for us to be able to compute probabilities involving the sample mean x bar. And in a similar way, it's going to be useful for us to be able to compute probabilities involving the sample proportion as well. We haven't really talked about sample proportions all that much. We have talked about proportions, or in other words, percentages, right? And we've talked about probabilities of success. All of these things really go hand in hand, and they're really all kind of the same thing. So let me kind of introduce you to the sample proportion real quick, and then we'll talk about the sampling distribution of the sample proportion. Okay, so first of all, proportions and sample proportions are related to binomial distributions because we can consider an individual who has some characteristic to be a success and an individual who doesn't have that characteristic to be a failure, right? So it's a binomial type of situation. They either have the characteristic in question or they don't, right? The proportion of individuals who have the characteristic, so the proportion of individuals who have the characteristic would be the probability of success, right? So the proportion who have the characteristic is the same as the probability that a randomly selected individual has the characteristic, right? So the proportion is the same as the probability of success in a binomial experiment. That proportion, P, right, that probability of success, that's a parameter. So it's usually difficult or impossible to obtain. And so we estimate it, and we estimate it with the sample proportion. The sample proportion is written this way. So it's a P with a little circumflex over it. That's read P hat. So we would read that P hat. Okay. The sample proportion is pretty easy to compute. It's just you would just take the number of individuals who have the characteristic and divide it by your sample size. Okay. So P hat is X over N, where X is the number of individuals with the characteristic and N is your sample size. Okay. For example, Opinion Dynamics Corporation conducted a survey of 1,000 adult Americans aged 18 or older and asked, "Are you currently on some form of low carbohydrate diet?" Of those surveyed, that should say surveyed, right? Of those surveyed, 150 said they were. Find the sample proportion of individuals surveyed who were on a low-carb diet. Okay, so the sample proportion, P hat. Well, it would be the number of people who had the characteristic, right? 150 said they were on a low-carb diet, divided by the total number of people who were asked, right? The total number of people surveyed, right? We had a survey of 1,000 adult Americans. So P hat would be 150 over 1,000. Oh, we could do this in our heads, right? We just move the decimal 3 times to the left. So I'm going to say this is, if I move this 1, 2, 3 times, it's 0.15. So the sample proportion is 0.15, or in other words, 15%, right? 15% of people are on a low carb, or 15% of the people in this particular survey, right, are on a low carb diet. So that's the sample proportion. Now, just like with the sample mean, the sample proportion is likely to differ from one sample to the next. And consequently, we can think of P hat as a random variable, okay? Using this same example, it's like if you took a different sample of 1,000 people, maybe only 149 of them would have been on a low-carb diet in that case, and so P hat would have been 0.149. Or you took another sample of 1,000 people, and maybe 173 of them were on a low-carb diet, right? So then the sample proportion of that sample would be 0.173. Okay, so P hat is going to change from one sample to the next and and consequently p hat's a random variable. What we want to do in this section is describe the sampling distribution of p hat. So if you took a bunch of samples of size 1000 and you computed the sample proportion for each of those samples, what is the shape, center, and spread of that distribution of the sample proportions? Okay, that's what we want to be able to figure out. The center, we can kind of reason out in our heads just thinking through it a little bit. Okay, so let's think about, what do you think the mean of the sample proportions would be equal to? Mu sub, so we're going to denote that by mu sub p hat, right? The mean of the sample proportions, mu sub p hat. Well, let's think about this. So you take a bunch of samples of size 1000 and you compute all of the sample proportions, right? One of the sample proportions might be 0.15, and another one might be 0.17, and another one might be 0.14, and so forth, right? But you do all of this for a bunch of samples of size 1000, and then you take the average of all of those sample proportions, right? So you would say 0.15 plus 0.17 plus 0.14 plus blah, 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 and divide by however many samples you took, right? What do you think the result of that is going to be? So I'll give you a second to pause the video and think about it. Okay? And then I'm going to give you the answer now. So if you take a bunch of samples, compute the sample proportions, and then take the average of those sample proportions, what you're going to end up with is the population proportion. Okay, think about it. It's like if the true population proportion, let's say that the true population proportion in this case is really 16%, right? So so in our particular sample here, we were a little less than average. But if the true population proportion is 16%, you might get a sample where the sample proportion is 15%, but then you'll get another sample where the sample proportion is 17%, right? And when you average all of those up, you're going to get 16%, right? So the mean of the sample proportions is equal to the population proportion. Okay. Let's investigate this a little more, right? So we're pretty sure the center of our distribution, mu sub p hat, is going to be the same as the population proportion. But what's the shape of the distribution, and what's the spread of the distribution, right? What's the standard deviation of p hat? So we're going to run some simulations. I might start a new video to run the simulations. I want to do 3 of these with 3 different sample sizes. So we're going to simulate something taking samples of size 10, and then size 25, and then size 60. So I'll start a new video, and then we'll run all of the simulations together.